Greetings to everyone. This is Lwandile here, the leader and the instructor of Manikwa School. Today we're actually going to be doing exercise 2.9. As you guys can see, I've already created a project, call it 2.9, and inside that project I created a class, called exercise 2.9c. So right now we gotta jump onto this textbook we're actually using and then go straight to exercise 2.9. This is the question. If you haven't yet looked at it, what you gotta do though is to go through this exercise by yourself before you proceed watching this video. Otherwise you'll be wasting your time. So average acceleration is defined as the change of velocity divided by the time taken to make the change. As shown in the following formula, A is equals to that. We gotta write a program that prompts the user to enter the starting velocity VO in meters per second, the ending velocity in meters per second, and the time span T in seconds, and display the average acceleration. So here is a sample run. As we all can see, now it's time to do the coding. Okay, so because we do have student A and student B's solutions, okay, student C knows how important it is to avoid redundant, how do you spell that? Redundant, doesn't matter. Okay, so student C knows how to avoid using variables unnecessarily. Really, I hope I got that right, and if I did. Okay, student C knows how important it is to avoid using variables unnecessarily. Okay, so here's how student C go about solving this straightforward problem. Again, this is pretty straightforward. We could have had a single solution for this, but I thought, you see, the fact that the reason why I'm actually repeating this stuff is because I know, I've seen tons of beginners making one and the same mistake. The mistake of not commencing your code, and the mistake of having undescriptive variables. Okay, so what we're doing here, we're creating a scanner. Okay, so what you're doing here, we closing a scanner. Okay, and then we need a double variable to hold a final velocity, initial velocity, and the time span. That's pretty much it. That's all you're gonna need, and then we're simply gonna prompt a user to enter V0, V1, and T. then store those on their corresponding variables. Velocity equals to, no, actually you gotta start with the initial velocity, which is simply gonna be equals to input dot next. I hope you guys can see that the order matters. I mean, the order in which you read or you assign your user inputs into your variables matters, because since the user will be giving us an initial velocity first, our program will be reading that first, right? And secondly, the user, since we know the user will give us the final velocity, then our program should also read the final velocity secondly. Okay, and then lastly we'll be reading the time span, whatever amount of time it took that object to change from v0 to v1. Okay, what we do right now, we gotta simply display that system.out.print. We'll be using printf again in order to make sure we have correct number of decimal points. The average acceleration is let's just go percentage 3 point, let's just go for f, and then let's avoid using a variable, because in this case that variable will only be used, I mean on this problem that variable will only be used once. Velocity minus initial velocity. So we're basically wasting our memory by having a variable that will actually hold the average acceleration itself. So since we'll be using it once, we might as well not have a variable holding that computed number. Okay, time span. So this is it. Let's see what we get if we do this. Let's hit the as you might have noticed, you guys, I am not, once I do a problem, I do not bother myself with other inputs such as this. For instance, let's say we have that and that and that. I don't do this. By the way, the negative here, it simply means that this object is decelerating, so it's changing, its speed is decreasing, right? So its speed, because we have vf minus vi, so which means its final velocity is actually less than its initial velocity. So we basically, this thing is actually accelerating, it's not decelerating. I don't know if it did physics, but you get what I'm trying to say here. Anyways, what I was saying is, I hope you guys noticed, I don't do this. I don't put different values, because you can do that by yourself. But if you feel like I messed up, in case like you decided to do things the way I did and you happen to get weird results, weird outputs, just let me know in the comments, because as I mentioned, you guys, I am not a robot, I'm not a machine, I make mistakes. So if you are a programmer, you've got to know it's an infinite path of learning. So that's pretty much it, you guys. See you on the next tutorial. Cheers, I'm gone.